Let me welcome everybody to this year's Harris Lecture. Many of you have been at our lectures before. The William and Myrtle Harris Distinguished Lecture Series in Science and Civilization goes back all the way to 1996 with generous support from the Harris family, and they've been extraordinary in contributing to the activities that have enabled us to bring distinguished scientists and scholars here to speak with us. Bill Harris, who is a Caltech graduate, got his bachelor's and master's degree here in mechanical engineering and is still an active member of the Associates. Today's speaker is Myles Jackson. Myles is, as you can see, the Albert Schoenberg Professor in the History of Science in the School of Historical Studies at the Institute for Advanced Study. He was previously at NYU, where he was Professor of History and in the Division of Medical Ethics, and I was Gallatin Research Excellence Professor there for a while. He's the author of 3 books. His first one, The Spectrum of Belief, was about Fraunhofer and the development of Fraunhofer's lenses and so on. Then Harmonious Fields on Music and Physics in the 19th century. And most lately, The Genealogy of the Gene, in which Myles was involved in some of the court cases concerning gene patenting, testified in New York, I believe, at the trials and so on. And in most recent times, he has been working on what he's going to talk about today, engineering fidelity, early radio, and the trautonium in Berlin in the 1920s and 1930s. Myles is a German speaker at this point and has had many awards. He's a member of the Académie Internationale d'Histoire des Sciences and of the German National Academy of Sciences, Leopoldina. Questions that come in over YouTube, I will be able to see here, and I will field them afterwards. Myles can ask if anybody in the audience has questions, can come up, but I'll be right here. Myles.
Thank you very much, Jed. Thanks everybody for coming. I'll lecture in English, even though I do speak German. We were going to play a game and say this lecture will be in German, but then I figured that wouldn't be funny and everyone will leave. So, and since there's booze out there, I don't want you to drink the booze before I'm done, otherwise I don't get any. I want to thank for the invitation to give the Harris lecture. It's great to be back at Caltech. Although I'm a historian, I don't read papers. I hate that crap. So I'm going to just do a show. It's a fun show. Many thanks for coming. Hopefully you won't regret it. Many thanks for those on Zoom. And I know my wife and my little daughter, who's now 2, are either going to watch it now or later. So many thanks to my wife for taking a hit for the team so that I could be out here for a few days. And many thanks for Charlotte for waking me up every 2 hours when she was an infant, because a lot of what I'm going to talk about today, I spoke to her as a 2-month-old, 3-month, 4-month, and she had this amazing look as if to say, Daddy, what in the world are you doing? And if she soiled her diaper, I knew I had a basically not doing well, and she'd fall asleep every time. So hopefully you won't fall asleep, but without Charlotte, I don't think I would have been able to write this paper, this show. So without further ado, this is probably the most difficult slide to get through because Noel, unfortunately, is no longer with us. When I'd come back periodically to Caltech, we had a lot of conversations about this project. He was an amazing musicologist. A lot of people don't realize just that Noel's training was in musicology. He was an amazing font of information for so many things. And the only thing we ever disagreed on was Wagner, because he's a Wagner fan. And I'm fascinated by Wagner, but I'm certainly no fan. So I only hope that this lecture does his memory credit. As a historian, I thought I'd start with a great story. If we turn on a stereo today, say a Bose or Blaupunkt or something, even doesn't have to be that good. And generally, if you have the most minimal amount of education, you can tell the difference between a cello and a piano, or a drum and a trumpet. If you cannot, this lecture is going to be very boring to you, and you can leave, and I'm not going to say anything. But radios today have no problem broadcasting what we now call tone color. In the 1920s, they did. So let's go back to 1925. Let's say April 1925. And let's go back to Berlin before it goes horribly wrong 8 years later. So we're still safe. And we're listening to the radio, and it's the Busch Quartet. It's the Heilige Dankgesang, which is the third movement of Beethoven, one of the late string quartets, number 15 in A minor, opus 132, third movement. And you are shocked and horrified because the violin sounds like they replaced it with a clarinet. And at times sounds like they replaced it with a violin. A violin with a flute. You know, it's 1920s Berlin, and it's pretty wild and crazy, but there's some things you just don't do, like Jim Croce once sang, you don't tug on Superman's cape, you don't spit into the wind, you don't pull the mask of the Lone Ranger, and you don't mess with Ludwig van Beethoven. So what in the world is going on? And this is actually a true story. There are letters in the archive of the University of Arts, Universität der Künste in Berlin, of irate Germans writing very nasty letters to the local radio station, which was the first public radio station in Germany, was to be known as Funkstunde Berlin, saying, how dare you mess with Beethoven in Germany? Because the director was very Prussian, he felt obligated to answer all the letters, which he did, and he even put an ad in the newspaper saying, look, we didn't substitute a violin with a clarinet or with a flute. It's just that radio has a problem broadcasting fidelity of tone color. So what in the world is tone color, also known by its French term timbre or Klangfarbe in German? Helmholtz's definition is it's the upper partials of a note in their relevant amplitudes. So because I play the cello, if we start with the fundamental frequency of the open A, that's 220 hertz, the first upper partial would be double that, or 440. Second upper partial, 3 times that, 660. Third upper partial, 4 times that, 880. And the relative amplitudes of those upper partials determine the tone color of the instrument. Timbres are very difficult to reproduce, as I said, over radio. The Georg Schunemann, who is basically the dean of the Berlin Conservatoire, wrote in 1927, orchestral pieces were distorted by the radio such that in one piece the basses seemed to be absent, in another the drums. The violin sounded like clarinets and the concert piano sounded like an old square piano. The lower pitches of the cello sounded like a horn. The lower pitches of double basses often were too low to be broadcast. The high range of a violin sounded like a flute, the lower range like a clarinet. Again, quoting Schunemann, the sounds of percussion instruments, particularly timpani, would often shrivel away to a faint bang or a dry, short beat with an imprecise pitch. The interesting thing, there are many interesting things going on in the story, but it's also the time in which in the 1920s there's a debate about timbre. Is it only the relationship of the upper partials in terms of amplitude? Was there something else going on? Is it static, like Helmholtz said, or is it dynamic? And what is the role of psychology and physiology to timbre? And the people in my story are asking and answering those kinds of questions. It's not just a musical instrument problem, and it's not just a problem in Germany. It's a problem with those who broadcast radio. So another interesting story, and this is actually encapsulated in Scientific American, October 1928. Not so long ago, an elderly gentleman whose aristocratic appearance was impaired by a distinct frown, don't you hate when that happens, entered a radio store and addressed the clerk as follows: "You sold me a receiver some time ago. I wish you would send someone to my home to fix my set. I hear nothing but screeching sopranos. Here's my address. Thank you." And to show that I'm not making it up, that's the actual article. It was written by Ryder, who was an engineer, a radio engineer, and also a musician. And it was untitled, "Why is a Radio Soprano Unpopular?" This, as I said, you read about this in France, you read it in Britain, you read this in Italy, Germany, and the United States. All of my historical actors basically said it's the Germans and the Americans that do the most to solve the problem. The Americans are led by those, although they're not the only ones working, the major players, of course, are the Bell Telephone Lab folks. And so the radio engineer Edward Nelson writes, "As long as music and entertainment continue to hold a prominent place on broadcasting programs, fidelity of transmission will probably remain the most sought-for characteristic, not only for the radio transmitter itself, but for all of the apparatus units in the system." One of the leading German acousticians, Erwin Meyer, says, "Speech and language broadcasts must possess fidelity. A whole series of scientific investigations had to be carried out in order to recognize which conditions had to be met in order to guarantee a fidelitous reproduction of sound processes of any kind." German telegraph engineer Steidler, 1925. The problem of electric broadcast of lectures and musical performance leads to a frontier of technology and art, which gives the telegraph engineer a number of new tasks to solve that fall outside the framework of the general rail transport technology. The electrical engineer Lubzinski, it is certainly not said enough that acoustics, which had previously been the stepchild of physics, has surely not only come to experience many new stimuli through radio, but has also now become quite modern. Maya, the acoustician, went a tad further. A new branch of technical acoustics, electrical acoustics, came into being as a result of the impulse from the radio. And how about Weisskopf? And I didn't know who he was until several weeks ago, because he ended up on the West Coast. He was a musician. His parents said, you can't be a musician, you'll be poor. You better become an engineer. He becomes an engineer. He leaves Germany during the war, comes to the United States, finishing his musical education. He is the director of the Portland Opera Company in Portland, Oregon in the 1960s and 70s, and the director of the Beverly Hills Symphony Orchestra in the 1970s and 1980s. He writes two opposing professions which previously had no relation with each other, namely the electrical, particularly the radio engineer, and the musician now engage with one another. Out of this marriage, the musical engineer is born, which is seen as a paradox today, but tomorrow might be taken for granted. That term, Musiktechniker, gets changed a little bit and becomes Tonmeister, sound engineers. The 1920s in Berlin is basically where sound engineering is going to be invented, rather critically by these players. So what in the world's going on in my story? I mean, if you're Sheila Javanoff, you talk about co-production. It's about the rise of public radio, the creation of public radio that necessitates radio fidelity. As a result of that, we have a new branch of acoustics, electroacoustics, and you also have the creation of a new musical aesthetic. It's Neue Sachlichkeit. It gets translated as new objectivity. I like new thinginess, although no one uses that, which is very famous in the art movement. There's also a musical movement, and I'll talk about this a little bit today, and also Rundfunkmusik, which literally translates as radio music. It's not just music that's played over the radio, it's music that is composed for the radio. Think of it, the broadcasting room of a radio station is a bizarre place. I don't know if any of you have ever played on them. It's not like a 19th century a musical hall, right, or concert hall. It's not like a salon room of the 17th century. It's a bizarre place, and there are a lot of articles in the 1920s about the psychology of playing in a radio broadcasting booth. And so there are many debates that what type of music do we need to compose new music, and how do we have to change previously composed music so that it works over the radio? The causes of the fidelity, on the one hand, you have the transmitter. Many, but certainly not all, broadcasting stations in the United States, in Germany in the 1920s, had some problems. They could not sufficiently intensify the sound waves after they were picked up by the microphone. They transmitted, therefore, the upper partials were not translated in the correct proportion, thereby distorting the tone color. Amplifiers of your own receiver would not correct for that, indeed would only amplify the error. That was a problem. Loudspeakers at this time are not very good. The upper range of pitches and the lower range of pitches of an orchestra, the upper partials were not broadcast well at all. So there were important technological reasons, but there's also a governmental restriction. Radio is very popular. It's popular in the United States. It's popular in Europe. As a result of that, you have a lot of people buying radios, and you have a lot of radio stations cropping up. If they're too close to each other on your AM dial, because FM is not quite here yet, and they're loud, you'll have heterodyning, you'll have interference. As a result of that, governments needed to give bandwidths, restrict bandwidths, to increase the number of stations that you could have. So given the physics of amplitude modulation, the bandwidths are 9 kilohertz. That means you have a sound, so it's important with amplitude modulation. You have the two sidebands plus your carrier frequency. So it would be 4,500 plus and minus the carrier frequency. What that means is anything more than 4,500 kilohertz, 4,500 hertz, 4.5 kilohertz will not be broadcast. If you're a soprano and you sing high C, in an opera, footnote, some operas go higher than high C. High C, this is now given equal temperament, give or take a few hertz. It was about 1,046 hertz. Now the fourth upper partial and higher will not be broadcast. That's why sopranos sound flat. And they sound flat in Germany, they sound flat in Italy, they sound flat in England, and they sound flat in the United States, right? It's a ubiquitous phenomenon. So what my story does is I take two bits of material culture, because I love material culture. That's why Karl Marx is you probably can't see it, but the sticker on my laptop is Karl Marx, is early German radio and this really bizarre instrument called the trautonium. And I use them as a heuristic tool to probe various boundaries of knowledge and disciplines in Germany in the 1920s and 30s. And I'll stop my story in 1963, which is the hint to Nico about what the surprise will be. So it's a very early history, very brief history of early German radio. It's a story about the collaboration, the active collaboration of physicists, electrical engineers, physiologists, and musicians. Physiologists, because with the rise of radio dramas, it's important to be able to distinguish voices, which is not that straightforward. After 1933, it's very important in Germany for all people to know what Adolf Hitler sounds like on a radio. So there's a lot of research on improving I'll talk about formants of speech analysis. The place where the crucible, where they ply their craft, is because it's a German thing, it's a long word, the Rundfunkversuchsstelle, or the Radio Experimental Laboratory, the RVS, otherwise this talk becomes 4 hours. I say Rundfunkversuchsstelle every time. It's housed in the Berlin Conservatoire. It is the only laboratory worldwide working on these problems that are based in a conservatoire. Bell Labs, obviously, is not based in a conservatoire, right? The composers are not Huey, Dewey, Louie meets Larry, Moe, and Curly. They're Paul Hindemith. Paul Hindemith has a job at the RVS. He teaches at the RVS. He does research at the RVS on tone color. Mats Butting, Ernst Toch, all of these are composers of Neue Sachlichkeit. They're all researching on tone color, on playing with records, adding holes, changing speed. How does that change tone color? And Kurt Weill, Brecht's sidekick. You probably know Kurt Weill. Kurt Weill is, oh, der Haifisch, der hat Zähne. I can't sing, so I'll stop. But these are very important people, all of whom are dedicated to this new genre of Rundfunkmusik, and the RVS is supposed to help them improve that. As I said, the aesthetic is Neue Sachlichkeit. It's about order, precision, clarity. It's seen as being experimental. It's very anti-expressionism. And it has a foible for machines. So Hindemith composes a lot of work for machines. One of that will be, he considers the trautonium a machine. The intellectuals, not to say that, Hindemith and Butting, they are intellectuals as well, but intellectuals near and dear to a lot of people's hearts are fascinated by this. Brecht is very interested in the RVS because now radio will be improved such that the masses can be educated. That's very important to him. Walter Benjamin, if someone's going to say, das Kunstwerk im Zeitalter der technischen Reproduzierbarkeit, I'm going to scream, because Benjamin wrote a hell of a lot more, and I think stuff that's a lot better than that essay. He's interested in this. That essay, of course, is 1936. We're talking about the 1920s. He wrote over 80 plays, radio dramas, children's lessons on the radio, and lectures for the radio. So he's very much interested, A, in this new genre, and B, the RVS. And then you have none other than Theodor Adorno. We all know about Adorno's infamous diatribe against jazz. In the 1920s, he's interested in radio. He's interested in radio fidelity. And indeed, in 1938, a man by the name of Max Horkheimer writes a reference to his friend Paul Lazarsfeld, who's a sociologist at Princeton, saying, there's this young guy, he's pretty smart, Theodor Adorno. He's interested in radio. Why don't you, so he sails to the United States. Princeton has the Princeton Radio Project. It's funded by the Rockefeller Foundation. And its goal is to study the mass media, such as radio, on the education of the American public. Adorno is fascinated by this. He researches this. He actually publishes an article that he wrote in English, footnote. He should have written it in German because it's torturous to go through. 1941, called The Radio Symphony, an Experiment in Theory. And it's a total lambasting of those who claim that when you listen to Beethoven symphonies, specifically discusses Beethoven, on a radio, that you really understand Beethoven. If you want to understand Beethoven, you have to go in a concert hall, right? Why? The radio at that time was too atomistic. It was too reductionist. You don't get Beethoven unfolding over the radio in the 1920s and the 1930s. You don't get the range of volume because of fidelity issues. And you don't get the correct tone color in the radio. So he says, he's actually quite harsh. He says, for the workers and their wives who think that they listen to Beethoven, which being as a Marxist is a bit interesting, you're totally wrong if you think you're listening to radio and you're understanding the Beethoven experience. Whoops. And the trautonium is a story that fits right into this context. It's invented in the RVS. Paul Hindemith plays a very important role. He actually has decisions about the design that the thing takes. So I talk a bit about before, during, and after World War II. I always like to say it's the most famous instrument you've likely heard, but never heard of. And so hold that thought to the last slide. Some of you might know already what it is. So the context, very briefly, of German radio, the first ever radio program, public radio program in Germany was the 29th of October, 1923 in Berlin. Radio was under the control of the Imperial Post Office. It had to be two things. It had to be educational and entertaining. Germans needed to be entertained in 1923 because it was not a good year, right? That's the year of hyperinflation. It's the year where there are skirmishes between the Nazi Party, which is now 3 years old, and the Spartacans of the Marxists in Berlin. There are separatists that want to go to France. It was also to be überparteilich, which literally means above party politics. It was to be objective. Now, as we all know, in 1932, before 1933, that changes. That changes with von Papen. When Hindenburg puts Papen in, in 1932, the state begins to control radio. That's why in 1933, when the Nazis come to power, it's actually quite easy for Goebbels to usurp it because von Papen has already done the groundwork for that. By the 1st of April, 1929, Germany has more radio listeners than anyone in Europe. It surpasses Britain. So given the number of radio licenses, the Germans are very anal. They actually tell you how many licenses they have every frickin' 3 months, which is great, but I wouldn't want that job. And demographers tell me there are about 4 people per family. So about 18% of the population had a radio. The important bit is it wasn't equally dispersed. Members of upper middle class had it, and people who lived in the city, because if you're living in a farm in Prussia or Upper Silesia, reception ain't going to be that great. It's a lot easier to get reception in major cities like Berlin or Hamburg. So there are 2 institutes that are critical to the story. I can talk about the Heinrich Hertz Institute of Oscillations Research. It's important, not as important as the RVS that I'll be talking about. It was directed by Carl Willi Wagner, a very brilliant electrical engineer who was professor at the Technische Hochschule Berlin, the Technical University. Had 4 departments: radio technology, telephony and telegraphy, acoustics and mechanics. Focused on radio, TV, sound movie technologies. Architectural acoustics is very important, and electric music. We now call it electronic. It's called electric music. It's called electric music until basically after World War II. Then you hear it more as electronic music. But we would call it electronic music today. And the Rundfunkversuchsstelle, the RVS. Again, it was founded on the 3rd of May, 1928 in the Berlin Conservatoire, and it's headed up by Schunemann. What are the goals? Study how sounds of voices and musical instruments are distorted by radio and correct it. Footnote, that's a very easy thing to say, not so easy to do. You also have to improve the genre of Rundfunkmusik. That's why the composers are participating. There's debate saying, Wagner, this is where Noel and I would fight, Wagner doesn't sound really good in radio. I would always say Wagner doesn't sound good anytime. I'm sorry if you're a Wagner fan, but I'm really not a Wagner fan. He's a fascinating person. He does amazing things with music. I just don't find him aesthetically pleasing. So they basically say, Parsifal's too long. Let's have the greatest hits of Parsifal for 1 hour and 30 minutes on the radio. You can imagine what the Wagnerian, the true fans, would go thermonuclear. And they also talked about, okay, we need to reduce the orchestra because it's a very tiny recording studio. And some of them like Butting and Weil said, no, we have to compose an entirely different music. This is our chance. We have a new genre that we have to educate the masses for, and radio is the way forward. It's a time when the carbon microphone design was undergoing change, massive changes. It's also a time where you have condensed microphones, ribbon microphones, moving coil microphones, piezoelectric microphones. Why? Because of radio. Radio creates this amazing market that necessitates improvements on these things. It's also a time where you have vast improvements in loudspeakers. And what the RVS would do is that they tested carbon microphones. They compared it. They compared the ones made by Telefunken and Siemens and Halske and other, and Allgemeine Elektrizitätsgesellschaft. And they weren't meant to be propaganda. It was kind of like a standards laboratory. They'd report back and said, you know, your loudspeaker, very good for the ranges of 500 to 2,000 hertz. Above that, the fidelity's problematic, so on and so forth. So they were a testing laboratory. And finally, the RVS was a place where you're supposed to make electronic musical instruments. And that's where the trautonium gets created. So it's a story about the research of upper partials. I talked about this in the beginning a bit. Helmholtz gives us, I mean, when in doubt, the answer is always Helmholtz. In 1859, he publishes an essay called On Toncolor über die Klangfarbe. He elaborates that on the sensation of tone of 1863. He uses tuning forks and his resonators famously. And he basically says that, you know, he shows that the relative strength of upper partials determine a vowels characteristic. Remember, Helmholtz is a doctor. He's a really good physicist too, but he's actually educated as a physician. And it also gives the musical instrument its timbre. And later on in physiology, Ludemann Hermann says, no, Helmholtz got it wrong. So this is in the 1890s. He uses tuning forks and resonators. Look, has nothing to do with resonance. That when you're talking about vowel sounds, it's about the glottis having spurts or impulses of air that initiate transients, natural frequencies in the oral cavity. They dampen decay, they're damped in decay, and they give the instrument or the voice its characteristic sound. And that's called formants. He actually invented the word formant in the 1890s. Karl Stumpf, who's the director of the Institute for Psychology, who works on physiology, he's also a musicologist, using tuning forks and interference tubes and reed pipes, says, you know, Helmholtz's theory, pretty much by and large true. Hermann said they're inharmonic upper partials. Helmholtz said they're only harmonic. Stumpf says, no, Helmholtz got that right, but they're both wrong because they're not singular pitches, they're pitch ranges that determine formants or tone color. For those that are worried about Helmholtz, it turns out that when in doubt, ask Lord Rayleigh. Lord Rayleigh shows that Hermann and Helmholtz theories are actually the same. One is a limiting factor of the other. So they predict the phenomena equally well, and their variations on the same. In physics, you had Dayton Clarence Miller using tuning forks, who's interested. He's a flautist, as well as a professor of physics at Case Institute for Applied Science, which becomes Case Western Reserve. He uses tuning forks to determine the timbre of various instruments. And then there's Carl Willi Wagner of the Heinrich Hertz Institute for Oscillations. He uses electric circuits. He's interested in voice transmission because it's World War I, and it's very important to tell the troops where they need to go via radio. After the war, he works on acoustical formants of spoken language, spoken and sung vowels, as well as musical instruments as the director of the Heinrich Hertz Institute. So the $64,000, how does one measure tone color? How does one have a scientific method for determining something such as tone color? And that's where harmonic analyzers come in. They're invented by Lord Kelvin. They're used for tide prediction. They're used to graph changes in air pressure and temperature throughout the day. It turns out Dayton Miller is going to use one made by Corradi, this 1916. Corradi is a Swiss instrument maker. Because Dayton said, well, look, there are sound waves. We can analyze this using a harmonic analyzer. The ultimate trivia question Dayton Miller studied with Michelson. Michelson as in Michelson-Morley, as in Einstein is all wrong, as in Michelson used harmonic analyzers to analyze light waves. Dayton Clarence Miller says, I'm going to use it for analyzing sound waves. By the late 20s, early 30s, they become much more advanced and sophisticated. This is a recording electric harmonic analyzer at Siemens and Halske, which is now called Siemens. So what they basically did is they used tone colors. They would look at the relative amplitudes of upper partials. They would compare the oscillograms of someone playing the violin or someone singing a particular vowel, and then compare that with the oscillograms of that instrument or voice over the radio and see how the distortions played out, right? Again, the leading players, Bell Telephone Labs, the names in red are clearly the important ones. The most important by far is clearly Harvey Fletcher. In Germany, you had a bunch of people, Trendelenburg, Siemens and Halske, Erwin Meyer, who was in the Imperial Office of Telegraph Technology and also the Heinrich Hertz Institute, Grützmacher, also in the Office of Telegraph Technology, and Walter Gerlach, a name many people would know, the universities of Tübingen and München. So with that Wagnerian, the talk isn't that long, so don't worry. With that kind of first section at the end, I can talk about the instrument, because this instrument, I'm so fired up. So the first bit's about radio, and I'll tell about how it's linked in just a second. This is Phyllis Krautwein. He's the inventor of the trautonium. He's a really sinister shit. I mean, I don't know how else to say it. It's very depressing working on him, and I'll explain why in just a minute. He grew up in Heidelberg, studied physics. He was a young organist in his church. He decides to stop studying physics. I don't know why. He then switched to law, and he wanted to work with the post office, but he wanted to be a kind of a patent lawyer. He was interested in technologies, radio technologies, and intellectual property. World War I comes, he's the head of a radio squadron. That's rather important. After the end of World War I, he returns and finishes a PhD in electrical engineering at Karlsruhe. He has 2 patents, this is 1922. 1922 and 1924, he receives 2 patents for generating musical notes using electric circuits, which become rather important for his instrument. And that's the trautonium that I will discuss. So he goes, after he finishes his PhD, he goes to Berlin in 1923. He works with a number of the kind of the startup electric companies in Germany. He also works on that first radio station, Funkstunde Berlin. In 1930, he's hired as a docent in the RVS, and his homework assignment is analyze the problem of electric formation, transmission of sound, distortion of tone colors, and make we now say electronic, musical instruments. Those are his homework assignments. And he does rather well at both. The thing that ties both, the radio and the trautonium together is the trautonium is a musical instrument that can change its tone color. You turn a dial, it sounds like a violin. Turn the dial again, it sounds like a flute. Turn the dial again, it sounds like a French horn. Right? So it's the tone color is the key, and the creation of tone color. Now, when I first started this and reading this in front of a 6-month-old baby who looked at me as if to say, I'm never going to do the history of science, that's for sure. I assumed that you would take the oscillograms and reverse engineer the harmonic amplitudes. You can't do that. It does not work. And Krautwein realizes that early on. Why? Human hearing is not linear. So what a machine hears as various amplitude different, a human ear does not. If you take a pitch at, say, 100, where our hearing is not that great, compared to 2000, you need a much stronger signal amplitude of the 100 hertz sound in order to sound to our ears to be equivalent to 2000, right? So they have to work around, they can't reverse engineer it. And also, and this is critical, tone color isn't static. It changes over time. It's the envelope, we now say the acoustical envelope. The trautonium is the first instrument ever created. It's not the Hammond organ, it's the trautonium with the acoustical envelope taken into consideration. That's why it's really good at reproducing various tone colors. So by using various types of circuits with resistors and capacitors, it's a classic kind of radio equipment, he could produce the tone colors that resembled numerous musical instruments. The fundamental frequency was a glow lamp circuit. It was altered by changing the resistance and capacitance of the circuit that changed the frequency. And he had additional resonant circuits tuned to different frequencies via low and high pass filters that would then generate the tone color, the additional upper partials. The two key aspects of the trautonium, on the one hand, it could mimic. So mimesis is critical. It could mimic a bunch of musical instruments. It was important for Hausmusik, or music of the home in Germany. On the other hand, it creates new, wonderful, modernistic actors' categories, sounds. And when in its history, which one gets emphasized is very, very interesting. It actually starts, and the physiologists are interested, the first sounds they actually make are vowel sounds. It actually produces vowel and word sounds before the vocoder comes, before Homer Dudley has his vocoder. So this is quoting Zala, who's the assistant on the project. We, Trautwein and Zala, tried out many beautiful things there. He once arrived, Trautwein, with a thick transformer and said, I brought this along. Now let's connect it up and then we'll add a capacitor. Just a small one. And all of a sudden we were amazed to hear oo, o, a, o, u, e, e. That would be the German vowel. we were speechless. He, Trautwein too, of course. Naturally, he had thought about it. He thought it ought to work, but when it really does, you exclaim, wow. You might say that the revelation for everyone, that was a revelation for every one of us. We now had a range of tone colors for if you play with an ooh, you get sounds ooh, 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 ooh. If you play with an A, it's ah, 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 ah. And he goes on and says, we immediately realized the similarity between certain vowel sounds and those generated by musical instruments. The vowel ooh in a bassoon, O in a clarinet, A in an English horn, E in an oboe, several shades of the vowel A in the saxophone, mixture of U and E in the cello, mixture of A and I in the violin. So they quickly go from physiology and speech to music. So what do? You compare the oscillograms. There were a study by Trendelenburg in 1925. He has the oscillograms of the formants of the various vowels and consonants. Oscillograms of violins were produced by Backhaus, who was at Siemens and then later on at the University of Greifswald. And Trautwein, in his work Electric Music or Electronic Music, a comparison of the resulting vibrational forms of the trautonium's formants with the characteristic oscillograms of musical instruments and speech sounds reveal a noticeable conformity. As a matter of fact, this is, he calls it, the circuit for physiological fundamental experiment. He writes, the trautonium is an electrical analogy of the mechanism of sound creation of the human speech organs. The scientific significance lies in the physico-physiological impression of the synthetically generated sounds compared with the timbre of numerous musical instruments and speech sounds. This suggests that the physical processes are related in many cases, right? The interesting bit is that, it's much more interesting as a musical instrument. It's actually for Trautwein a scientific instrument because he's convinced that it's proof positive that Helmholtz is wrong and that Hamann is right. Because what he basically says, Hamann, remember, says the way in which vowel sounds are created is that puffs of air through the glottis initiate transients in the oral cavity. They're damped and decay. That's basically equivalent of sending electrical pulses. The electrical pulses then are damped and decay, and they form the characteristic sound of the instrument. Again, there is no, Helmholtz and Hamann are basically the same theory, but Trautwein is convinced that his work is proof positive, that his instrument is proof positive, that Ludwig Hamann is correct. So, as I said, the instrument as a musical instrument is more interesting. It's interesting, for this show it's more interesting. There you have Trautwein, upper left, that's Paul Hindemith with the horrible bow tie, and that's Oskar Zala, the very famous virtuoso on the instrument, and that's one of Hindemith's violin students. I don't know who that person is. Hindemith composes for the trautonium. This is the first ever trautonium piece composed. It's published in 1930. This is Zala, again, this is the man, and that's a trautonium that I'll get to that. He is the virtuoso. This is the Ur-Trautonium. This is the first one ever built in 1930. You can see that it's a strip of wire. You press the wire, connect the electric circuit. By turning those knobs, up the I don't know if I have a pointer, but I hate to press buttons I do, touchdown. These knobs determine the formants. So you literally turn a dial or flip a switch in order to change the tone color, and here obviously is the pedal to increase the volume. Other pictures in the inside bits of the trautonium. Again, it's typical kind of circuitry, vacuum tubes. This is 1930 at Neue Musik Berlin, the music festival of new music, and this is, thank God for YouTube, this is the first ever piece for a trautonium, 1930. After that Wagnerian introduction. Yep, here we go. Oskar Zala is playing it, and I don't know if you can see.
Trautonium vorführen.
That's Trautwein standing up. Flips the switch, change tone color. Lower. Now, it was a start. It had mixed reviews, and I can talk about reviews in the questions if you want. They continue working at it. In 1931, they decided to also power it with a battery as well as AC current. The glow lamp was replaced with a thyrotron, which is a typical radio signaling piece of equipment. And he produced the Volkstrautonium, or the trautonium of the people, in 1933. It was marketed by Telefunken, the famous company, and it was meant to be Hausmusik for educated Germans wearing funny clothes. There's the panel, and the amazing thing is that this is only 3 years after the original archetypal trautonium, and they're now playing Paganini. For those that play violin or flute or cello, that ain't easy. And the tone color is supposed to be a flute, by the way. So F is actually for Formants. That's the dial that changes the format. There, you see it right there, Formants. There's kind of the house music of the German family playing together with the trautonium. And you could buy it from Telefunken if you wanted to. It was not as popular, we can talk about that, it wasn't as popular as they had hoped. From 33 to 36, they continue working on it. Krautwein kind of disappears after 35. Zala, from 1935 onwards, all the trautoniums are his. These are some of the kind of the post Volkstrautonium models. This is 1937. The Reichs Radio Society commissions Telefunken to build a large, what's called a radio trautonium that's housed in the radio station in Berlin. They decide they want a portable version, and that's in 1940. Again, Oskar Zala is the only one building it. Trautwein is doing other things. And that's the concert trautonium that tours. It tours throughout Germany. It tours throughout occupied countries. It tours throughout allied countries. The trautonium was the electronic musical instrument most featured during the Third Reich, which is fascinating to think about. They also, it's part of their propaganda. This again, thank God for YouTube. This is Utrecht, 1942. And you don't, I mean, you can always pretend to speak Dutch. It's kind of like German.
Door de professor Oscar Zala een demonstratie gegeven op het trautonium. Deze uitvinding van Krautwein is een melodisch instrument waarvoor de elektriciteit slechts de kracht levert tot het voortbrengen van de toon. De bespeler regelt de stroom en de trillingen en kan deze trillingen in oneindige schakeringen en klankkleuren vervormen. De uitvoeringen die hier te landen met dit instrument worden gegeven staan onder leiding van generaal muziekdirector Zaun, dirigent van het Stedelijk Orkest van Berlijn.
Es ist mir eine ganz besondere Freude, anlässlich meines ersten Auftretens in Holland, nicht nur das neue elektrische Musikinstrument, das Trautonium, vorführen zu können, sondern gleichzeitig auch für einen jungen deutschen Komponisten einzutreten. Harald Gensmer hat eigens für das Trautonium ein Konzert
playing the piano. He's actually a composer for the trautonium.
Zala will be playing the trautonium. In Utrecht und außerdem im niederländischen Rundfunk zum ersten Male außerhalb Deutschlands zu Gehör bringen. Ich hoffe, dass Ihnen das neue Instrument gefallen möge und wir werden uns gestatten, nunmehr einige Proben praktisch vorzuführen.
Tuning it is not straightforward, by the way, in case you're interested. It's actually rather it's a pain in the butt. Notice now you have two strings, two rails, rather than the one. This is Gensmer's Fantasie, composed in 1940. And there's obviously piano coming. So obviously, we're talking about the Nazis, right? It's 1933. The relationship of the Nazis to electronic music was strange at best. The relationship with Hindemith is kind of like a Facebook, it's complicated. He was not liked among a lot of members of the Nazi Party. Then in the early, in 33, 34, he starts to use folk songs incorporating into his works. Goebbels actually likes him. The man who's more of a Nazi, Alfred Rosenberg, who out-Nazis Goebbels, no joke, doesn't like Hindemith. Goebbels saves him for a bit, and then comes Matthew the Painter, in which there's a naked lady in the opera, and it was moral degeneracy. Even Goebbels couldn't save him anymore. He labels him an atonal noisemaker. Hindemith accepts a position from the Nazi Party in Ankara to start a German music institute. He actually has a vote of support for Hitler. And it was rather opportunistic. Things didn't improve. He emigrates to Switzerland and then to the United States, where he takes a position up at Yale. Goebbels shuts down the RVS in 1935, but it's not that he destroys it. He simply transfers it to other bits of the Berlin Conservatoire, and it is headed up by Trautwein, who receives the professorship now. So Trautwein runs it. The Conservatoire and the Heinrich Hertz Institute were cleansed of Jews and Marxists, so that you no longer called it the Heinrich Hertz Institute. You called it the Institute for Oscillations Research. Trautwein and Zala are extremely opportunistic. Trautwein, it was not just opportunistic. He was a committed Nazi. He joins the party on the 1st of April, 1933. For those that know German history, that's the same date where the Germans stopped buying Jewish merchants. Kauf nicht bei Juden ein. That's the 1st of April, 1933. And he's a member of the Sturmabteilung. He joins it about a year later. Trautwein assists the Nazis in designing acoustical loudspeakers for their massive rallies in places such as Stettin, Nürnberg, Vienna, Wien. Goebbels has a personal meeting with Trautwein and Zala. He wants to hear the trautonium. He says, mach mal weiter, please continue. He said, this is fascinating. It can be a household instrument. He wants to know if it can be used at mass rallies, right? For him, it's actually supported by the various instantiations of the trautonium, were supported by the Reichskammermusik, which is the Nazi Party support of the music, basically the Nazi Musical Association. He calls the aesthetic of the trautonium steely romanticism, Stahlene Romantik, which is very typical kind of Nazi-esque notion of musical aesthetics. It's featured on the radio intermissions of the Berlin Olympic Games of 1936. It's over 150 radio concerts, dozens of live performances during the Reich. It is undoubtedly the leading electronic musical instrument of the Nazis. It is not an example of degenerative music at all, entartete Musik, although Hindemith is considered degenerative in 1936. That you're not allowed to perform Hindemith after that in Nazi Germany. And a wonderful archival find, which always is depressing. This is actually the instrument that Goebbels heard. You can actually see here on Minister Dr. Goebbels. And this is from Oskar Zala. Oskar Zala's Nachlass, his archive. He was released not that long ago to the Deutsches Museum. So a lot of this stuff is not really that well known. War comes to an end, what happens? The moral to the story is if you're a member of the Nazi Party and your team loses, it's hard to get a job. And Trautwein really can't get a job. He works a bit making a monochord, which is kind of a version of a trautonium, for the very famous studio for electronic music in Cologne, right? That's where people like Stockhausen are going to become rather famous. The founding director is Herbert Eimert. Then there's a very famous physicist and physiologist, Werner Meyer-Eppler. They have huge debates that are fascinating, and it's important to the early years of electronic music because the question is, what is the role of the instrument player to the composition? People like Stockhausen wanted the purity of the electron, and it's a very religious thing for Stockhausen. That's why a lot of the early music from the Cologne studio was going back to the original kind of pure tone. People like Trautwein and Zala say, no, the musical instrument is absolutely critical to electronic music. So there's an interesting debate. The legacy of Trautwein, probably other than this trautonium, is he creates the first sound engineering curriculum at the University of Düsseldorf in 1952. The concert trautonium, Zala, because he was not a member of the Nazi Party, things go much better for him. It's featured live and on the radio. He does classical works. He also plays contemporary works. Now it's used to play strange modernistic music that the Nazis generally were not fans of. So you have this great debate of, should it be mimicry or imitation on the one hand, or the generation of new sounds and tone colors on the other? It could do both from day one, but after World War II, it's important that it dissociates itself with its Nazi past. It's featured in radio dramas, sound effects for theater pieces. I don't know if you know Paul Dessau is a very famous theater director. He directs Faust I, Faust I in 1949 because it's the 200th anniversary of Goethe's birth. And of course, Goethe was hijacked by the Nazis. So Paul Dessau was interested in having an instrument that made futuristic sounds to dissociate with the Nazi past. And so he uses the trautonium and says, don't do the kind of shit you did with the Nazis, but unleash this futuristic kind of orientation. So you have a musical instrument that effaces its past, can efface its past and invent a new tradition, to steal Eric Hobsbawm's phrase. It also is it's used in movies. It's a substitute for instruments and classical works. It plays the F trumpet bit in Brandenburg Concerto No. 2. It actually plays the Graz Glockenklavier, which is the instrument that Wagner once made for Parsifal. They don't have it's after the war, they don't have the Graz Glockenklavier, it's destroyed. So the trautonium takes over in that bit. That is the last instantiation of the trautonium, the mixture trautonium, 1952, and that's Oskar Sahle. It's used to produce the bell and hammering sounds in Meistersinger von Nürnberg and Bayreuth. For those that are, and this is where Noel would be jumping up and down. Wieland Wagner tried to distance himself from the Wagner family because they were Nazis and friends of Hitler. Wieland also was, by the way, a Nazi who worked on Peenemünde and the V2, we now know. So this kind of, I'm not like my parents is not true. But it's interesting is that the Meistersinger von Nürnberg was Hitler's favorite opera of all of the Wagner operas. And the ultimate trivia question is it's the only opera that's played in Bayreuth in 1943 and 1944. The only one, right? In 1945, they're not doing anything, right? It's near the end. So the question then becomes, how does Wieland Wagner deal with this post-war production of Meistersinger von Nürnberg with the trautonium that the Nazis liked? Well, you make it produce wonderful, bizarre sounds like the Graz Glockenspiel. And for those that are Wagner fans or opera fans, Wieland Wagner is famous for his minimalist sets because the Meistersinger von Nürnberg during World War II were the most elaborate medieval scenes. I think one of the reasons why Hitler loved it so much. It's also music for industry films, Creation Without an End, Aluminum, Portrait of a Metal, and Steel. So a lot of the German big pharma and metal companies and chemical companies use the instrument as an example of the modernism of modernity and science theme. It also is music for cultural films, Anders als du und ich, or different from you and I, for you and me in English. 1957 is the first film about homosexuality in the Federal Republic of Germany, in West Germany. And indeed, the argument was they were talking about gay men who were interested in bizarre forms of art and the trautonium. It was also featured in 2 ballets of which it was only electronic music. Pan was choreographed by Grozowski. The music was by Oskar Sahle and Remy Gassmann, premiered in 1960. More famously, Electronics, which is choreographed by the late, great George Balanchine up in New York. Again, Sahle's trautonium performs the music. But most famously, remember I said in the beginning, this is the most famous instrument you've heard but never heard of. Do you know, Nico? No? Do you know? Go ahead. No. There's Alfred Hitchcock, and the film is this one. Ah! I knew I was going to blow that. After that Wagnerian ending, the sound of the birds are, this would have been so great had I not. After that Wagnerian. Anyway, The sound of the birds is the mixture trautonium. Those are not real birds. So the screeching sound of the bird calls and the flapping of the wings is the mixture trautonium. Do you want to enable Ask Siri? No, I don't. That's ugly. Almost as ugly as the mood. So what's kind of the Wagnerian ending of this one, even though I blew the birds bit? Where do we go from there? Obviously, FM, you have a really impressively improved fidelity in the late 1920s, very early 1930s, and you can hear that with, recorded radio broadcasts. You have the rise of FM radio. It's actually invented by Armstrong in the 1930s, frequency modulation. It does not get, it's only not until 1978 that the number of people listening to FM are greater than the number listening to AM in the United States. It takes a while to catch on in interesting ways. For those that are more modern than I am, you might or might not know of Dieter Zeitzer, who was a founding director of the Fraunhofer Institute for Integrated Circuits. His work led to the MP3 player, and MP3 is kind of the opposite thing. Because in this case, you want to know how much information you need in order to convey a tone color. MP3 is how much information can you take out without destroying the tone color. And indeed, Zeitzer actually is fascinated by the trautonium and sees himself as being kind of like the final story about that. There are other forms. The trautonium influences other electronic musical instruments. There's one, the Laboratory for Acoustical Musical Grenzprobleme, like frontier problems, which is in the former German Democratic Republic, East Germany. They have the sub-harcourt of 1960. You probably all know about the Moog synthesizer. I knew Herb Deutsch very well. He's the musician who collaborated with Herb Deutsch. With Robert Moog on the Moog synthesizer. He basically said that the whole subharmonicum, the semi-modular synthesizer of the Moog, owes itself to the trautonium. For those that like Kraftwerk, Kraftwerk certainly sees themselves in this tradition of Werner Meyer-Eppler and the trautonium. The Love Parade in Berlin, electrono-technic dance music. Those are the descendants of my story. So it's about the story of the simultaneous construction of radio fidelity, electroacoustics, musical aesthetics. So again, I'm interested in the material culture of early German radio and the trautonium. I use them as a heuristic tools, to basically challenge our preconceived notions that somehow, that these disciplines are absolutely distinct. I think I'm shedding a new light on however we want to determine modernity, to show that by using two pieces of material culture, early German radio and that trautonium, that the kind of the disciplinarity that seems so entrenched in our world actually isn't nearly as entrenched as we think it is. And I think the trautonium is really a classic example of that. So many thanks for your time, and I'm here for questions, although there is booze outside, so you probably don't want to ask that much. But also I have the email in case I'm here, but you can also email me. Thank you so much for your time.
Where's the Hammond B3 fit into this?
So the question is, where's the Hammond B3? The Hammond organ is an important instrument that also uses, is produced for synthesizing the tone of an organ. It also uses the envelope, but it's after the trautonium. It's not until the late 1930s. So actually, Krautwein is convinced later on, and there's no evidence of this, that Hammond organ gets its ideas from his trautonium. He actually tries to sue, and he fails, because these are all patented. These are all intellectual property issues. So the Hammond organ is actually a very classic example of an instrument that can have a very good tone color, but it's not. It comes after the actual trautonium. And Trautwein's convinced they sold his technology. It's based on similar things, but it has to be said that the notion that circuits can produce different types of overtones is well known by the mid-1920s.
It's partly done with some sort of rotating speaker.
That's exactly right. It's done, and where the interesting thing is that you have a speaker in the trautonium, but often you can hook it up into your radio. You can actually hook up your trautonium. So the speaker element is certainly original to Hammond. That's not a bit from the trautonium. That's absolutely true. Yep. Yes. I don't know anyone's name, so.
Charles.
Hey, Charles.
So two questions. The first so you mentioned all of these irate letters to the
Yes,
radio.
yeah.
Were there any maybe open-minded listeners who found things worth paying attention to about these distortions? Maybe I'm thinking with my own aesthetic about distortion being maybe something that gets
Right.
interesting. Then the second question is about percussion, because you mentioned in that same section a lot of people complaining, the timpani sounds terrible. All of the recordings you played were sort of more like clarinets and
Correct.
string sounds. So I was wondering, at the RVS, are people interested in problems specific to percussion and how to kind of make this work over broadcast?
Yeah, so I have to repeat the question apparently. Right, I repeat it because the people on Zoom apparently get. So the first question is, were there any enlightened Germans who basically say distortion's not a bad thing, but it's a new type of musical aesthetic? The listeners, no. Because the listeners look like the letters I read now, they might not have been deposited. All the letters I read are complaining. People like Hindemith and Butting and Toch are very fascinated by distortions, right? So the experiment that Hindemith does with Toch, one of the major composers of Neue Sachlichkeit, is that they put an extra hole in a record, in a gramophone disc, and change the velocity in order to distort the type of sound to see what influence that has on tone color. And they actually have a composition that is based on precisely that work. So the composers at the RVS are very much interested in it. The listeners sound like they're old grandmas and grandpas. The handwriting like they're 1,000 years old. All the letters that I've read are very much opposed to it. The composers see it's a problem because we're playing Beethoven, but there are areas in which we can bring the Neue Sachlichkeit music, we can play with distortion. The second question is, what about timpani? Since I didn't talk, most of the stuff you're right, the clips you have are, the first bit was like various stringed instruments. The second clip was about a flute, right, was set flute-esque. Timpani, the percussion instrument they find very, very difficult to analyze. It's very tricky for them. They just cannot reproduce that tone color very, very well. And I'd be interested if there anyone, I know that bells are phenomenally difficult to synthesize those sounds because of the physics and electrical engineering that go into that, the computer music that go into that. That was timpani, the percussion instruments and timpani were very difficult to recreate for the RVS. So that's why you don't have, and I think a lot of that has to do with the fact that in, say, for something like timpani, you have a lot of inharmonic upper partials. There's a lot of noise over basic band. These people are emphasizing the fact that the tone color are multiple integers of the fundamental frequency, which is true of more characteristic, more a typical acoustical instrument. Does that begin? So they are interested in it, but you cannot turn a trautonium and make it sound like a drum. And they would like to, but they can't do it. Mm-hmm.
Thank you so much, Mike. What about the relationship?
Is that Alexander? Is that Mahlzeit? Hello.
What's the relationship between the trautonium and the theremin? Because
Yes.
an element for creating futuristic
Yep.
space sounds, and I believe created at the same time. Right?
Yes, the theremin is a little bit early, but it's about the same time by Theremin, who is a Russian. It's based on it's based on heterodyning. So you have two. It's fascinating. I try to play the theremin. I'm a cellist. I need tactile kind of information. But you have your two hands. One hand determines the pitch. The other hand determines the volume. So you have two antennas, an electric field, and you enter your hands in that field. It's certainly futuristic. Krautwein very much knows about it. He doesn't like it. He calls it Bolshevik. Because it's Russian. And he also is worried he doesn't want the trautonium to become kitschy like he says RCA did with the theremin. So a lot of theremins were actually disposed of. That was not nearly as successful. So it is the most important precursor instrument to the trautonium, although it's based on totally different physics. And when you have reviews of the period, they compare it to the trautonium. They compare the trautonium and the theremin, saying they're both examples of electronic music, but they're based on different systems that have totally different sounds. For those on Zoom, the question is, how does this relate to the theremin? It's about the same time, and Theremin was a cellist as well as a very good electrical engineer, and his instrument is very, very popular in the Weimar Republic, the most popular musical instrument in the Weimar Republic.
Can you hear me okay?
Yeah, I'm fine. Yeah, sorry.
So how about the influence of American electronic
Yes.
music, beginning with the telharmonium back
Yes.
in the late 1800s.
Yep.
And then, as you mentioned, RCA also had
That's right.
a very big room-filling synthesizer.
In the 50s. Yes.
What was the cross-pollination?
That's very, very good question. They certainly know about the dynamophone of Cahill, right? On the late 19th, this was an amazing instrument that was an electric device that sent music through telephone wires and caused massive interference, and so it then dies. They see that the trautonium as being a part of that tradition. They don't draw upon the technology all that much. The interesting comparison is with Bell Labs, because they do know each other very well, and they invite. I mean, Harvey Fletcher to the Germans is about as good as it's going to get. And this is, I have to say, footnote, this is the work of Mara Myles, who's a very, very good scholar at NYU, which she works on sound studies. The interesting thing about Bell Labs is that their initial research is on the spoken voice, much more so than it is in music. Harvey Fletcher does write, there's a fascinating experiment very late in 1935 about the transmission of an orchestra, Philadelphia Symphony Orchestra to Washington, D.C. via radio with various microphones and loudspeaker setups. But most of the stuff coming in Bell Labs is coming on formants of the spoken word. Where my story, this is a conservatoire. And even actors in the 1920s say the Germans are much more interested in music, particularly electronic music. You're right, Bell Labs, RCL and Bell Labs will get interested in electronic music, but it's much, much later. It's post-World War II, right? It's 1950s. So the Germans are the first to use this technology with an interest in furthering electronic music that the Americans then, particularly Bell Labs and RCA, pick up on in the 1950s.
Actually, one more question.
Yeah, please, yes, yep.
So I'm actually reading a book right now about the Copenhagen interpretation.
Yep. Okay.
How philosophy definitely affected Bohr and sort of the whole approach to quantum physics and
Right.
quantum mechanics. So, you identified a bunch of intellectuals getting involved, and since this was sort of a similar time period,
Yep.
were philosophies like positivism and whatnot, were they influencing both sort of the technique, but also the aesthetic design?
Repeat it.
The question is whether positivism affected philosophies in general, especially in Europe, are going to influence what's going on with the trautonium. That's a great question. I mean, certainly, I'm interested in how. I mean, so there's Peter Gallison's work on the Bauhaus, right, and the influence of logical positivism in architecture. You do have a logical positivist strand in music. It's not a direct influence upon people like Trautwein. I don't even think Trautwein knows of it that much. Certainly Hindemith does. So the composers are very much aware of these. It doesn't get translated at the level, sadly, of the instrument, like it does get translated, as Peter Gallison shows, architecture at the level of Bauhaus. That was something I hoped, and I spoke to Peter a lot about this, and we looked at various sources, and we never had something of a smoking. Hindemith certainly knows about this. It's not important for Oskar Zahler or for Trautwein. Sadly. I wish it worked, because that would be the slam dunk of all things. Yeah, Elliot.
One last question.
Yes.
Today. Is there a trautonium app for your Mac?
Good question. There is a trautonium app that's not very good. And there is only one, and this is the moral to the story, there's only one surviving trautonium player. And it's Peter Pichler, who lives in Munich. And the problem all throughout was that that's a damn hard thing to play. And so Oskar Zahler always talks about, I want to create a trautonium school. And this tragedy was he had a trautonium school. There's actually a book, Trautonium Schule, which is to help train trautonianists. He had a class of 6 people at the Berlin Conservatoire, and they all died during the war. So it doesn't last. He then has to rebuild it. There is a concert trautonium that exists. He has it rebuilt. It was damaged somewhat in the war. Tries again to have a school, and it's just too difficult to play. And also, the repertoire is, things that very few people actually composed for the trautonium. So you would play Paganini, or you would play Beethoven, you'd play Handel, right? Occasionally there were some, but the compositions by Gensma weren't really that great, so people just were not interested in going into it. And it's an interesting skill mix. It really is good for stringed instruments, but the more complex it gets, it almost becomes more keyboard-esque. So if you looked at one of the designs, they still have 2 strings, but you had levers that were in thirds and fifths so that you can play these virtuosic parts. So the skill set required to play it was not very well. I mean, you literally had to train a group of people in many different techniques before they were. So there is an app, it's not very good, and there's only one professional trautonium player in the world today. In Munich, and I'll see him. I know him, and he wants to come to the United States, but it costs $25,000 to bring the trautonium to the United States. So it's better to have the app, even though the app isn't that good.
Well, time has moved on. There's a reception upstairs that please everybody could attend. I want to thank Myles again for a fascinating talk.
Thank you. Thank you for that. Thank you, everybody.